Now, as I told you earlier, there are some theorems, some concepts. Using these theorems and concepts, we can do the problems on remainders easily. So in the series, we have Firmness Theorem over here. So what does it say? If P is a prime and A is any number prime to P, right? It is not necessary that A should be any prime number. It is any number, but P and A that should be co-prime to each other. Then A raised to P minus 1 is divisible by P. Okay? Or in other words, or result of this theorem is if P is prime and A is any number whatever, then A raised to P minus A is divisible by P. So this is actually Firmness theorem. So what exactly it says, I just explain you over here. Listen to me carefully. A raised to P minus 1 is divisible by P. Okay, so what I can say, it is Px. Okay, or A raised to P minus 1 is equal to Px plus 1. That means if A raised to P minus 1 is divided by P, the remainder will be 1, provided P is prime. Okay, listen to me very carefully. Just note it down very carefully, because you cannot apply this theorem everywhere. Okay, there is a condition that this number P should be prime. Okay, so A raised to P minus 1, if it is divided by P, the remainder will be 1. Okay, so I just give you a simple example. A can be any number. That means suppose you have 2 raised to 16. So 2 raised to 16, if you divide by 17, then the remainder will be 1. Okay, that means precisely 2 raised to 16 is basically 2 raised to 17 minus 1. So you can compare. And 17 is a prime number. So 2 raised to 16, if it is divided by 17, the remainder will be 1. Now suppose you have very big number over here. Instead of 16, suppose you have 2 raised to 64. Okay, so 2 raised to 64 divided by 17, what will be the remainder? So this, we can reduce this to this. So what I can do, 2 raised to now, as I told you, this number can be any number. Okay, this number can be any number. That means A can be any number. So over here, 2 raised to 4, that means basically it is 16. So 16 raised to 16, if divided by 17, the remainder will be 1. Okay, so you can convert this to this. Now suppose you have 2 raised to 65. Okay, 2 raised to 65, and you have to divide this by 17 to get the remainder. Then what you can do, you can convert this as to 2 raised to 64 into 2. Okay, now this is what 2 raised to 64, as I told you earlier, it will be 2 raised to 4 raised to 16. So that will give you the remainder as 1. So in this case, the remainder is 1, and that 1 into this 2. The overall remainder will be 2. Okay, so if 2 raised to 65 is divided by 17, the remainder will be 2. Okay, and that is I am using Firmness theorem over here. So this is just one simple example for Firmness theorem, though I will be taking difficult ones also, but just for the explanation of this theorem, I am taking these examples. And this one, if P is a prime and A is any number whatever, then A raised to P minus A is divisible by P. That means A raised to P minus A is multiple of P. Okay, so we can write as Px. That means A raised to P is equal to Px plus A. Now what is the difference between these two? In this case, if you divide A raised to P minus 1 by P, then the remainder is 1. In this case, if you divide A raised to, instead of A raised to P minus 1, over here it is A raised to P. So if A raised to P is divided by P, the remainder will be A, not 1 but A. Okay, this is nothing but you multiply this expression by A. So you'll be getting this thing. Okay, so this becomes a, over here it is apx and plus a. So a raised to p, and apx is definitely multiple of p, so you will not be getting remainder, and 1 that will be converted to a because you are multiplying both the sides with a. Okay, so uh, if 2 raised to 17 is there, and if you have to divide by 17, the remainder will be 2. Okay, the previous case I talked about 2 raised to 16 and the remainder was 1. But in this case, we have 2 raised to 17. Okay, the precisely it is just the same thing. Over here, the remainder will be 1. 1 into 2, the remainder is 2. Okay, so if a raised to p is divided by p, the remainder will be a. If a raised to p minus 1 divided by p, the remainder will be 1. Okay. So I hope you are clear with this. We'll be taking examples, but the only condition you have to take care, A and P should be co-prime to each other. Okay, A not necessary to be prime, but definitely it should be co-prime to P. That means you cannot take the combination of 3 and 15 precisely, right? Because 3 and 15 are not co-prime to each other. 15 is not prime, but it is multiple of 3. 3 and 15 are not co-prime to each other. Okay, so when there is a prime number and the other number that is co-prime to this prime, this number, then you can use Firmness theorem. Next we have Euler's concept. Euler, basically I just introduce Euler number first of all. Basically Euler number, maybe if you talk about any number x. Okay, so Euler number of x means the number of natural numbers, or we can say the number of numbers, natural numbers I am talking, which are less than x and co-prime to x. Okay, which are less than x and co-prime to x. Suppose we talk about 8. Okay, so 1, 2, 3, 4, 5, 6, 7. All these numbers are less than 8. But all these are not, they will not be counted as the Euler number because the number should be co-prime to 8. Okay, so I delete 2, I delete 4, I delete 6. So Euler number of 8 is 1, 2, 3, 4. Okay, Euler number is 4. That is number of natural numbers which are less than 8 and co-prime to 8. So there are 4 numbers which are less than 8 and they are co-prime to 8. Okay, so Euler number of 8 is 4. Similarly, if we talk about Euler number of 6, so then we have 1, 2, 3, 4 and 5. Okay, out of these 2, 3, 4. These 3 are not co-prime to 6. So we are left with 1 and 5. Okay, so Euler number of 6 is 2. So Euler gives us a formula by which we can calculate Euler number very easily, because see, if I talk about 6 and 8, these are really small numbers, we can easily calculate their Euler number manually. But suppose if they are big number, obviously if we talk about competitive exams, so nobody is going to ask 8 and 6 something like this, right? So if we have big numbers, then it will be really difficult for us to find out the Euler number. So Euler gives us a formula, so that I just discuss over here. So if at all we have to find out the Euler number of any number, maybe suppose Euler number of n. Okay, so Euler number of n is equal to n into 1 minus 1 upon a, 1 minus 1 upon b, and 1 minus 1 upon c, and so on, right? Where a, b, c, or maybe there are more number, they are prime factors of n. Okay, a, b, c are, I just write different prime factors of n. Okay. So suppose we have to find out the Euler number of 8. Now prime factor of 8 will be 2 cube. So prime factor is 2, right? 2 cube, we will not consider cube, but prime factor is 2. Okay, so I just write 8, 1 minus 1 upon 2. So that is 8 into 1 by 2, that is 4. So Euler number of 8 is 4. That means there are 4 numbers below 8 which are lesser than 8 and they are co-prime to 8, and that we have already calculated manually, right? So I just verified this formula, and similarly we can even go for 6 also. So Euler number of 6 is 6 into basically 6 is 2 into 3, so there are two factors, so 1 minus 1 upon 2 and 1 minus 1 upon 3. So it is 6 into 1 by 2 into 2 by 3. So it's 2. So Euler number of 6 is 2. That means there are two numbers which are co-prime to 6 and they are smaller than 6. Okay. Similarly, we can calculate the Euler number maybe for 25. So 25 is factor is 5. So 25 into 1 minus 1 by 5. So 25 into 4 by 5. So it is 20. So there are 20 numbers which are less than 25 and they are co-prime to 25. You can even go for the manual calculation from 1 to 24. You have 24 numbers, out of these 5, 10, 15 and 20. These 4 numbers are not co-prime to 25, right? So out of 24, if we deduct these 4, so we'll be getting 20. So Euler number of 25 is 20. So sometimes even if you are asked how many numbers which are smaller than this particular numbers are co-prime, means to this number. Okay, so precisely you have to find out Euler number. Means suppose you are asked how many numbers are there which are smaller than 20 and they are co-prime to 20. Okay, how many numbers are there which are smaller than 20 and they are co-prime to 20. So what you can do, you can find out the Euler number of 20. So 20 is 4 into 5, so we have 2 and 5 as factors. So 20 into 1 minus 1 by 2, 1 by 2, and 1 minus 1 by 5 is 4 by 5. So there are 8. So there are 8 numbers which are smaller than 20 and they are co-prime to 20. Okay. Even you wish, you can go for the manual calculation. So this is Euler number, Euler concept. Okay. So we will be using Euler concept and we'll be using Firmness theorem to find out the remainders in some cases when they are in some questions what happens, they take lot of time if we use binomial theorem only. So sometimes one or sometimes two or sometimes we need to use the more than two concepts, all the three concepts to find out the remainders. Okay, so I'll be taking some examples over here, and if you practice well with these concepts, these theorems, these methods, then you can do all the problems based on remainders very easily. Okay. Now how Euler number is useful to find out the remainders. Okay, so for that just note down the concept, the application. So when we have any number, maybe any number that is a, if a raised to en, right, is divided by n, the remainder will be 1. Okay, or what is en over here? That is Euler number of n, and n and a should be co-prime to each other. And if at all you multiply this number by any other number, any other integer, still the remainder will be 1 only, right? A raised to en. If you multiply this by maybe any number, any integer, that is suppose x, then also the remainder will be 1. So I just give you some examples where we will be using this application. One more thing. See, Euler number of, as I told you, Euler number is a number of numbers which are co-prime to a number and less than that particular number, right? So we calculated the Euler number of 8, 6, 20, 15, 25, right? So Euler number of any prime number, Euler number of any prime number will be what? Suppose we talk about a prime number, say 7. So Euler number of 7 will be what? That is 6. Because all numbers which are smaller than 7 are co-prime to 7, right? 1, 2, 3, 4, 5, 6. If we talk about Euler number of say 11, then it will be 10. Okay, so Euler number of any prime number is nothing but 1 less than the number. Okay, Euler number of 13 will be 12. Euler number of say 17 will be 16. Okay, Euler number of 19 will be 18. Right? I just take a very simple example of this concept. Say I have 5 raised to 16. Okay, 17, Euler number of 17 is 16. So if 5 raised to 16 is divided by 17, the remainder will be 1. Okay, and that we have already verified using Firmness theorem, right? Firmness theorem, I hope you are able to recall the Firmness theorem. 5 raised to 17 minus 1 divided by 17, the remainder will be 1. Okay, so that was Firmness theorem. I hope you are able to recall that. So, and this I have done using Euler's concept. Now suppose I have a question, 17 raised to 40 divided by 15, what is the remainder? Right. Now 17 and 15, they are co-prime to each other. So 17, what is the Euler number for 15? 15 factors are 5 and 3. So Euler number will be 15 into 1 minus 1 by 3, that is 2 by 3, and 1 minus 1 by 5, that is 4 by 5. Okay, so that's 8. That means 17 raised to 8, if it is divided by 15, the remainder will be 1. Okay, so this is basically this. Okay, so if 17 raised to 8 divided by 15, the remainder is 1. So 1 raised to 5, further the remainder will be 1. Okay, so in this case, the answer is 1. So using Euler's concept, we solve this problem very easily. You can even verify using binomial theorem. It's just a one-step process. Just for your conceptual clarity, otherwise no need to use both the concepts. So it is in the first step 2 raised to 40, that is 16 raised to 10, right? 2 raised to 4 and into 10. So 16 raised to 10, that is 1 raised to 10, that is 1. If I divide by 15, so remainder will be 1. So verified using binomial theorem. Okay, so both the concept should be clear. Firmness theorem, Euler's theorem, binomial theorem. We discussed the 3 things, not 2, not both, not 3, in fact 3 things. So now we'll be taking the questions using 1 or 2, which require 1 or 2 concepts. Okay. I solved this problem earlier, 2 raised to 1003 divided by 25, what is the remainder? Now the same problem I'll be solving using Euler's theorem. So we have to find out the Euler number for 25. So 25 into 4 by 5, right? 1 minus 1 by 5. 5 is the only factor of 25. So it's 20. Right. So Euler number 2 and 25 are co-prime to each other, and the Euler number is 20. So what we can do, 1003, I just keep 2 raised to 3 aside, and 2 raised to 1000. 1000 is multiple of 20. Okay, 50 times. Now in this case the remainder is 1. 2 raised to 20 when divided by 25 the remainder is 1, and 1 raised to 50 the final remainder will be 1. Now we are left with just 2 raised to 3, so that's 8. Okay, so we have already got the answer. Now we have two different methods to solve the same problem. Okay, you can go this way or this way. So sometimes if the power is difficult or very big, or the numbers, this number and this number, the divisor, if they are co-prime to each other, you can use even Euler's function to solve the problem. Okay, now we say this 3 raised to 340 divided by 341. 3 plus 1, 4 minus 4, 0. That means 341 is multiple of 11. So it is precisely 31 into 11. Okay, now 31 and 11, both of them are prime numbers. So 3 raised to 30 when divided by 31, remainder will be 1. So this is precisely 3 raised to 30 11 times. Okay, right, so it is basically 330. So we are left with the 3 raised to 10. Okay, so 3 raised to 340 reduced to 3 raised to 10 from 31. Now just write 3, I just take it separate. 3 cube, 3 cube and 3 cube, right? 27, 27, 27. So minus 4, minus 4, minus 4, right, from 31. So 3 times minus 4 I can take over here. 4 4s are 16, 4s are 64. So 31 2s are 62. So 2 into 3, 6. Precisely minus 6. So 31 minus 6, that means 25 is the remainder. So 3 raised to 340 divided by 31, 25 is the remainder. That means it is in 31x plus 25 format. From 11, further 3 raised to 10 and 34 divided by 11, the remainder is 1. Okay, this is 340 completely, and 3 raised to 10 divided by 11, remainder will be 1 according to Firmness theorem. So 1 raised to 34, the final remainder is 1. So it is 11y plus 1 format. So now we have to find out a number 31, that is in 31x plus 25 format and 11y plus 1 format. You can make the calculation simple because you want just one number that satisfy both the expressions, right? So you can equate the expression. So 31x plus 25 is equal to 11y plus 1. So y will be 31x plus 24 by 11. So if I put x as 1, so that is 31 plus 24, 55 by 11. That means y is equal to 5, right? So 11y, that is 55 plus 1, that is 56. So 56 is in 31x plus 25 format and 11y plus 1 format. That means if 3 raised to 340 divided by 341, the remainder will be 56. Okay, I hope you are clear.